Welcome, everybody. Here's our first slide. My name is Eileen Fernandez. I'm hoping everybody can hear me. John, you just want to say hello? Just say hello. We're doing a voice check here.
Yes, hello everyone. Hi.
And we are from Montclair State, and we are going to be talking to you this afternoon about some alternative assessments to support student mathematical understanding that we are experimenting with at Montclair State University.
So we've structured our webinar session into sort of four main categories. So we're going to start off by just giving a little bit of an overview and some history behind the course that we've developed that acts as a site for some of the alternative assessments we're going to share with you all today. Then we're actually going to go through two particularly successful alternative assessments that we've adapted for an online environment, namely what we call our equation wheel and another alternative assessment we call functionominos. And then we're just going to close out just by just sort of synthesizing everything, gathering some ideas, and thinking about how you might all be able to adapt these and bring them into your own practice.
So I'm going to get things going here with a course overview in history. I hope you can see that this slide provides a glimpse into our history with supporting underprepared students. And we actually suspect that you'll see a lot of your own experiences reflected in this history. You can see our experiences with traditional remediation for pre-calculus, the Emporium style delivery, which was so popular at one point, but that just didn't work out very well. And then we tried the co-requisite models, various types of co-requisite models of providing extra support at the same time that the students were actually taking the pre-calculus. But I hope you can see that the DFW rates were just skyrocketing in pre-calculus during this time. And the need for something new and something different was very, very pressing. We were very, very lucky that our chairperson was such an advocate for these students. And he had been rallying the administration for years to please let us try to design something new for these students so that they would have a better chance of success in learning in pre-calculus. And finally, in 2024, we got the go-ahead and we got together, and John and I are two of the co-designers, and we designed a course called Approaches to College Mathematics. For obvious reasons, the DFW rate is going to drop when you split up the courses, right? Because now there's a placement test that places underprepared students into the approaches to college mathematics. We're following up on that. We're doing some research on that, and we hope to report something on that soon. Hopefully, we'll be able to share it with your audience. But for today, our topic is alternative assessments, and it stems from the work that we did in developing this course.
So as far as the kinds of students that populate this new course, Approaches to College Mathematics, these are majority first semester STEM majors. So this is their very first semester in college broadly. And these students will need at least through their first semester of calculus for their respective tracks of study. So it's interesting that the students that we work with are kind of in this position where they're not only learning the math that they need for their respective fields of study and their future careers, but also trying to learn how to be college students at the same time, which is a particular challenge, having both of these simultaneously. So these students are also characterized by being in a situation such that they're very pivotal algebra coursework, maybe towards the end of middle school or beginning of high school, was affected by the pandemic. So they experienced this rapid shift online. And so the students that we see like often will need a lot of deep support with making these connections across key algebraic concepts. The students are placed into this course using our institution's placement test. And speaking just a little bit more to our institution broadly, Montclair State has a very high acceptance rate. In 2023, it was 87%, and it's still hovering around that number today. And our student body is largely very diverse. So historically, we're a Hispanic serving institution, and we have a lot of diversity with respect to full-time versus part-time, those who commute versus those who live on campus, as well as those who are traditional students, or it might be returning from either a gap year or a longer span of time in their education. So kind of balancing all of the needs of this very diverse body of students in this course.
So, with regard to course goals, we were very drawn to this quotation that said that you don't simply repeat what was done before that led to students' current disaffection with mathematics. And this quotation, we were so happy to find it. It resonated with what we believed, and this set us on a path for alternative approaches and alternative assessments, and just designing alternative experiences for these students. So we played with a lot of we designed a lot of game-based activities, very deliberate explorations where the solution wasn't some go-to procedure that would answer whatever the question was that was posed. Designing authentically collaborative experiences was one hell of a challenge. So not the kind of thing where the students say, you do A and B and I'll do C and D. Somebody was talking about that earlier this afternoon. And there was a lot of revisiting and revising of the work that they did, feedback and redoing things. And we wanted to be upfront about this. The reality of these students' challenges hit us so very, very hard. How disparate their needs were and how deeply their challenges were embedded in those needs. I told John I've been teaching for what feels like forever now. This is, if not the hardest course, it is easily like one of the top 2 hardest courses that I've ever taught in my life.
So, speaking a little more to how we designed the course and guided students through this experience to prepare them for being college students and also for the math they need for their future coursework and their studies, we sort of frame the course through these 2 overarching categories of objectives. So the first are these mathematical objectives, which is what is all the math that we need to ensure that they are familiar with for pre-calculus and beyond. So in our course, we do a lot of work with using graphs to solve various problems, exploring a wide variety of bivariate relationships, and also giving them a conceptual foundation for some of these key pre-calculus topics that we know that they will see in either the next semester or shortly after they take our course, including trigonometry, giving them some of those basics. But beyond the mathematical objectives, we also, in the design of our course, wanted to address growth objectives in the assessments that we provided them. And so these are really designed to just address like what will they need to develop to continue to be successful in higher education. So this includes things like overcoming obstacles, learning how to budget your time, navigating the resources available to them, collaborating with others, and just continuing to be reflective and mindful and connecting to the bigger picture. So we really think of these 2 categories as being very reciprocal and informing each other in the kinds of assessments that we provide to students. And so in this way, we were hoping to be responsive to the issues that we've seen students face in the past, and that STEM students face broadly, which is, having the content knowledge that they'll need, but also developing the perseverance they'll need to succeed in these very difficult fields of study.
All right. So how did we think about reframing assessments? So we wanted our assessments to be learning experiences for students. We wanted the students to view the assessments as opportunities for self-reflection and growth. We wanted the assessments to reflect what was happening in our classes, in our teaching, and in their learning. The assessments shouldn't feel like they were coming out of left field. We wanted to incorporate multiple representations and flexible entry points into our assessments. So, making the learning more widely accessible, but not making it any less challenging. And we spent, boy, did we spend a lot of time providing very tailored feedback on the work that the students submitted. John and I can both attest to that. And we just wanted you to know, along with these novel assessments that we were experimenting with, we also complemented this with more traditional assessments. And we did feel like this just created a very nice balance in how students could convey their learning in the class. And look at this nice connection to this AMATYC standard, which says, this is an AMATYC assessment standard, which says faculty will incorporate multiple strategies for formative and summative assessments to inform future pedagogical practices and to help students recognize their current understanding. So we were just so excited about that and connecting with your community.
And so with this history and background and sort of motivating why we designed things the way that we did, we want to start with walking you through one of our first alternative assessments. And so this is what we call the equation wheel. And so the purpose of this particular alternative assessment is really to get students to think about connecting representations of linear relationships, really feeling comfortable with navigating across, what are the ways that I can represent these: table, graph, equation, but also connecting that with the components of those representations, so intercepts, even various forms of equations, points, all of that. And so the way that we would guide students through using this assessment in class would be that students would form small groups, and everyone would have their own copy of this equation wheel. And so, for example, let's say in a typical class, like our classes tend to hover around 30, so we might have like around 7 groups or so, shooting for like 3 to 4 per group, something like that. And so each group will be given a set of information about a particular linear relationship. So group 1 might be given the x and y intercept for their relationship. Group 2 might have standard form of the linear equation for their relationship. And so their goal with their given information is to take what they have and fill in their equation wheel. And so through this task, students would be mindful of, okay, like, where am I starting? Where do I go next? What might be helpful, a future point to move to that I can immediately access with the information I've been given? And also, how do they just continue to push forward? Maybe there are certain representations that might not be easy to connect to, and how do they build those connections? And so what we'd like to invite you to do with us is to experience an online version of this kind of task that we've adapted using the Desmos/Amplify activity builder. So we typically have done this as a paper-based activity in class, but we're excited about the way that we've adapted it, and we think you will be too.
We're giving this a shot.
Yes, we think it'll be fun. And so we will shortly provide you a link. But to get sort of in the mindset of our students, we encourage you to think about, again, like, sort of where are you starting? Thinking about what information will we be providing you initially? How do you proceed from there? What might be your next sort of points of contact to fill in your respective wheel? And maybe what other decisions are you making? Like, how do you continue to persevere or just build these connections? And sort of what do you notice broadly?
Yeah, and these are all mathematical ways of thinking. These are exactly the kinds of mathematical ways of thinking that we want to support our students in.
Yes, absolutely. Absolutely. And so I'm going to go ahead and share a link in the chat. And so you'll see that in this activity, there are 7 slides total. And so each slide will correspond to a group number. And so we would invite you to go to the slide that corresponds to your group number by the first letter of your last name. So for example, I'm John O'Mara. So my last name starts with an O, and so I would go to group 4, where I would be given a graphical representation of my particular linear relationship, and then I'd move forward and go around the wheel. So when you go into the task, you'll notice that you'll have your own slide, you'll have your own wheel, and you can draw directly on it, you can type in it, and we've actually started off by filling in the information that we provided you originally. So we were thinking we'd like to give you a couple minutes just to sort of play around and explore. And we encourage you to share your thoughts as they emerge, definitely in the chat or otherwise. And maybe after a couple minutes, will sort of kind of look holistically at the things that you all are noticing and connecting it to what this experience looks like when we use this task with our students.
And we just want to make sure if anybody had any trouble signing in, let us know so we can help you. But just it's time to play.
Yes, yes. We're keeping an eye on the chat. So any thoughts that you have, we're totally open to it. We'd love to hear what you're thinking as you explore this. Oh, Bob, yeah, we see your message. So that's a good consideration actually, thinking about like when you're building your graph, um, the difficulty in, segment versus line. And so, uh, although we typically do this using like not online, not digitally, I suppose one workaround, we're open to what others might suggest, would be to use, and I think somebody else just made that comment, maybe using like the sketch tool with the pencil.
Yeah,
Even if you like build your segment and then maybe just extend the end segments, that might be helpful. That's a good thought. So there are
thank you,
even different ways.
Sophia.
Yeah, yeah. Thank you, Sophia. Definitely. So you can see there are even different ways in an online version of this kind of task that you might tackle. Even like filling in things like points or equations. Like you might think, even from a student's perspective, would it be more accessible if I just hand write things or even try to type it in? Especially when notation gets more complicated, one might be more useful than the other. So I think we'll maybe give like another minute or so just to let you keep playing, um, and then we'll see we'll see what we all noticed and what we all did. Just as we kind of start to prepare to sort of look more as a whole, I'm actually gonna leave our slides for a moment and go over to the teacher view here for the activity. And so we actually something that we really appreciate about the Amplify environment is I know when I've been teaching, sometimes students like they'll feel really like targeted if I have their name up there and ask them to speak to it. We chose to anonymize it, and so that's always a fun feature. I think Amplify just chooses famous mathematicians' names, which is even a fun way to get students have asked like where do those names come from? That's a great conversation starter. Um, And so just kind of, I'm just picking some here for us to focus on. Uh, this is really nice. Um, and so we can see here, like using kind of the pencil tool was the primary approach here, which was great. Even looking across other groups. So I don't know, I might skip to group 3, for example. Um, and so here, again, like you might even be thinking as I'm going across to even different groups that some of these features might look kind of similar. There might be variations, of course, but even it looks like the line that group 5 drew was very, very, very similar, almost identical to the one from group 1. And so this would be sort of our big reveal for our students that although they all initially saw the information that every other group had, they may not have realized that every group was actually working with the same exact relationship. And so that's kind of every time we've done this in class, it's this big like light bulb aha moment that these students experience. That's a lot of fun and energizing. Um,
Yeah, we do this. I've had students put their equation wheels up on whiteboards, and they're so cute. They start looking at each other's wheels, and they're like, "Do they have the same line that I have?" And sometimes I've also had them draw their equation wheels on poster paper, and they all walk up to the front of the room and show their equation wheels, and they're looking, and they're like, "Wait a minute, some of that stuff looks the same as ours, and some of it looks different," and it's just they're so cute. They can't believe that they're this that you know that they have the same line. So it's very, very fun.
Absolutely, absolutely. And we've found that it's a task that really just invites students to make these connections between representations very organically. Um, and so even questions that we invite you to consider, that we have students consider when they work through this kind of activity, um, is reflecting on like what did the collaboration and sort of negotiation process look like in the decision making in their group. Um, and Even thinking about like once they sort of have this realization of, oh, these were all the same relationship, we push their thinking further by asking them, you know, what do you expect to be identical or different across different parts of the wheel? Like even if it's the same relationship, do all the tables have to look the same? When you build your graph, did you have to choose the same points? And so this pushing their thinking in this way, we've found has been a really supportive way of encouraging them to have fun with these relationships and making these connections, but getting deeper into the mathematics as well. And something that we'd like to leave you with as you reflect on maybe thinking about what could this look like in your classroom. We encourage you to think about, among other questions, what other mathematical questions or topics do you think that this kind of assessment could be used for? Or even, you know, we chose an equation wheel. Like, what other variations do you think might be appropriate or engaging for students? So we really appreciate your engagement with this. We've always found it to be a fun and exciting task, and we hope that that you see some relevance even that you might take into your classroom as well.
Sarah, I see your question about why a wheel and why not a table. And I did want you to know that we actually did, or I think a colleague and I experimented with something that was more table-like. And I don't know what it was about the wheel, but there was something just more engaging and interactive about the wheel for the students. There was just the motion of the wheel. The table was just kind of more rigid in how they approached it. So we abandoned it. We left it, and we just stuck with this format of the wheel. And there was just, I don't know, circles are special, and they turned out to be special in this situation too.
Yeah, absolutely. I do, Chris. I see your comment about making one group's equation different just to see what happens. I've actually never done that, but I like the educational chaos
Yeah.
that might start, the productive educational chaos.
Yeah.
So thank you all for sharing your ideas. And here we just wanted to share just some of the student reactions we've had to this activity. Really pointing us to the first bullet here. Students actually, like when after engaging with this in class, they saw this as an opportunity for them to prepare for future assessments like quizzes. And so this particular student took copies of them home and practiced working through two or three of them, setting a timer. And so we've seen that not only have students found this to be a valuable in-class alternative assessment, but even being able to take it out and using it for their own review purposes. So it has lended itself to, sort of a dynamic tool in that regard.
And this brings us to assessment two. So this is remember I said earlier that one of the things we did was we created games. So this is a game that we created and we called it Functionominos. What we did with this game, what we ended up doing was we took a set of dominoes, a set of 26 dominoes. And for those of you who don't know, dominoes is just a matching game. There's a certain number of pips on each of the tiles, and all you have to do is like you match 3 to 3 and and then 1 to 1, and you try to create these long chains. It's a game that's actually connected to, I'm Cuban, and there's a lot of gambling involved in dominoes with me growing up, but I think that's part of the reason that this game came to mind. But what you can do when you're creating a mathematical game is you take an existing game, and you map mathematical ideas onto the existing game. So for example, the mathematical ideas that we played with were types of relationships and different kinds of matching justifications that we had been learning. And we ended up with a set of new tiles. There are 2 examples of our tiles and a new game to play. So John, just go on to the next slide so we can explain this. Okay, so the mathematical ideas. What appears on each of the functionominos are types of relationships. So graphs of linear, piecewise, quadratic, exponential. These are all the kinds of relationships that we had been studying in approaches to college mathematics. And then the topics that we studied, those were the justifications for making matches. Right, is this relationship a function? What are their domains and ranges? Increasing, decreasing symmetries. These are all ideas that we had studied with them. And that was basically what created the match. Just so that you know, we gave them, I want to show you because I have the paper. See, I don't know if you can see, these are the paper functionominos in my hand. We gave them Post-its so that they could use the Post-its to kind of record their matching justifications at the junctures of the functionominos. We had the students play this game collaboratively, although you can play it competitively and try to get rid of your functionominos because that's the objective in the game of dominoes. And we put them into groups, and we just told them to start matching. Some additional rules just to make this a little bit more challenging. You can't use any one justification more than twice. If they were able to close a loop with all of the functionominos, they would get extra credit. And challenge justifications were that they could not make their matches just based on types of relations. So they couldn't create a chain that was just, well, these 2 are lines and these are matching quadratics and these are matching exponentials. I did want to say, this game was so incredibly engaging. There was no reaching for phones in this game. Students were out of their seats and there was a lot of revising, of prior connections so they could, if they wanted to close a loop, they would revise a prior connection. If they got stuck using a justification 3 times, they had to revise. So a lot of that was happening with this game. And we'll show you in a minute what some of their work looked like and how it was graded. But right now, John and I are going to, we've already done this, but this is fun. So look, we took a Canva kind of whiteboard, and there's a link. John's going to put that in to the chat. We're going in.
And so when you click on that link, you'll see this environment that I'm now sharing for all of us.
Okay, so hold on, John. Don't seem to be getting in. There it is. So again, this is a game, this is a paper game. This is played in person. This is not played in this environment. But you can see here, you can drag the tiles on Canva, right? And you can rotate them. Oh, John, we have so much activity. Maybe we should let some of these people make matches. What do you think?
Yeah, honestly, yeah, maybe let's do that.
Let's do it, guys. Anybody, just, I don't know, should I pick somebody? Jennifer, Marlene, who wants to make a match? Just volunteer in the chat that you want to make a match. Go for it.
We appreciate that it seems like we honestly we love that everyone seems really into just kind of moving things around.
Yeah.
We were thinking a lot about like how we might adapt this digitally, and we did land on Canva. Especially one big advantage is that like you can just kind of like zoom out and zoom in like infinitely. Like the space is really yours to do with what you wish.
So who wants to try to make a match? I see somebody. Sarah's typing something about domains.
Oh, I see. Nice. Yeah, the linear and the cubic.
There it is.
And that's
All
a yeah,
right.
that's great. That's a valid connection.
There's a juncture. Oh, I
Um,
see another one coming up.
I think I might suspect what's
Who's Tree
happening.
Frog? Oh,
Yeah,
John.
that's fun.
Coral, can you put a justification there?
Oh, nice.
You can type right into that box. Very nice.
And so something that's interesting that actually I didn't personally expect, but it's fun to see how you're all engaging. Is I see that some have made like copies of some of these functionaminos, and so in an online environment, of course, you know, as we said, we give these as like paper-based little pieces, and so they only have a finite amount that they can use to build a chain. But in an online environment, we you could even encourage students to say like, can you make copies and build like just as large of a branching out functionamino chain as you can. You can still include restrictions and things like you can only use justifications a certain amount of times, but the possibilities really open up, as you can
All right,
see.
we have a lone functionamino here that's not part of the family. Who wants to take it on?
Oh yeah, with the piecewise right there.
Let's see. Chris, what's the justification? Woohoo!
Ah, nice. That's a good one. That's great.
That's
And
so fun. Nicely done, everybody.
yeah, really. Yeah, and so we have a
Just so that
complete
you
chain here.
know, some of the the tiles and dominoes have blank slides, blank pieces on them. The one that Chris just moved, the left side of that is blank. And what we would do with those is the students could take the Post-its and draw a graph that would create a match that was desirable for them. So they would take the Post-it, draw a graph, and they would stick it onto the functionamino. And that way the functionamino is also reusable. We didn't want them drawing directly on the tiles. So um, yeah, this was one of our assessments.
Yeah, that was nice. And so I'll actually I might just
I think
share
we're
this in the
skipping.
chat. We do have an extra sort of larger one with more tiles. Maybe we'll leave this just so everyone has access to it. You can make your own copy and you can play with it. And just really keep thinking about, you know, all the possibilities, the ways that you might adapt this.
So here's actually Kelly gave us this idea. We really appreciated this. Here's something that you can do with functionaminos to kind of tweak it and make it, like more of a traditional assessment. Once they've played the game in class, you can write an item like, create a connector justification for this juncture and justify your response. So there's a drawn graph that I made, a linear graph, and students would have to guess, well, what's a good justification for that and explain it. And another one, using numbers in the tile slides, create two connectors using the functionaminos shown. So you can maybe some students might notice linking 1 to 3 as not being functions, and maybe linking 2 to 4. Let's go through, they y-intercept of 1. Yeah, those have a y-intercept of 1. So there's another match there. This is what their matches looked like. This was
This
so
is
much
awesome.
fun. They had to, so be careful because they had to stand on chairs and tables to take screenshots of this. But they would send, that's what they would send to us. And and we went around and we checked we checked the connectors, were they good? Did they falter anywhere? But this is what they submitted as a group, and this is what was graded.
And I did see a question, maybe a couple questions speaking to this in the chat, asking like, what does grading look like for this particular assessment? And that's a great
Yeah.
question. So, in for me and Eileen, of course, can also whatever variations that she implemented. So we would have students, they would have this experience in class, they'd work in these groups, and so they would take this sort of final snapshot of what their group produced. And so our assessment of this would be largely, qualitative and rubric based, of really looking for, did they use as many of the tiles as they possibly could? Really, were they up for the challenges and the restrictions we put in place? Are their justifications mathematically valid? So I saw somebody else mention, is there anything we were looking for in particular? I mean, I would say broadly, probably not. There are things that I might expect. I might look at a couple and say, oh, I could see students forming this connection. But there was honestly a tremendous amount of diversity. So as long as the justification's mathematically valid, those are really the kinds of things that we would look for.
Yeah, I remember I told John this little anecdote, but I remember the first time that I did functionaminos, um, there was a group that was working in the back, and they started and they looked at the table next to them, and the table next to them looked different than theirs. And then they looked at me and they were like, so wait, there's going to be all different answers for this? And I said, what do you think? And of course there were. And this kind of opened them up. They were actually looking for an answer or the answer, and then they realized, no, this is one of those situations where there are multiple valid approaches and solutions to this activity that we posed to them. But it was so interesting how that thinking had so permeated their brains that they actually stopped when they saw the table next to them doing something different.
Hmm,
So yeah, it was we love we love this game. We love these chains. It was just such an engaging activity.
definitely, definitely.
I'm trying to read the chat. Hold on. If you print something like this, you could add new types of functions. Oh yeah, even have them do an activity before defining something like exponentials, and then start asking them, thank you, Kelly. Kelly is just full of so many good
Oh yeah,
ideas.
that's a great
Thank
thought.
you, Kelly. That's very smart. Um, uh, so we did want to ask you, can you think of other topics, that we can create functionaminos for, or, can you think of other games that can be mathematized for learning and assessment? Because it's not just the takeaway of the actual game. This is what we did in order to think about this. And so we hope that, we certainly want you to think about this as the takeaway from this, not just the actual game, but just letting this be the takeaway. If anybody has anything that they can share. Um, we've got a vote for a series in Calc 2.
Oh, that would be
Oh,
fun.
look, which
Integrals.
one's yours? Oh,
Oh yeah, those are fun.
oh,
That's a good idea.
great.
I could even see with integrals like comparing the area, or even like going back to like approximations, um, even showing them different approximation methods. That's really good.
That's nice. That's really nice.
Um, so just to in our last couple minutes here, just to kind of like give some insight into some other things that we have done as alternative assessments in this course. Um, we've had students engage with doing partner quizzes. So these kinds of tasks that we showed with you, thinking about how can they actively collaborate and sort of transfer from homework completion to test taking, and really synthesize their understanding. Also, a big thing that we featured in our courses was giving them opportunities to revise. So, there may be an assessment or experience in class they struggled with, and so a follow-up task would be, take your work and see, reflect on where did things go wrong, why do you think it may have gone wrong, and really thinking about how can they, build a stronger bridge to the mathematics that they're engaging with and trying to understand. Um, these are just some more student reactions that we had to some of these alternative assessments. Even having students, voice discomfort, but seeing opportunities to teach others, um, and thinking about how collaboration can support them and how alternative assessments really push their learning and thinking.
Jen, I see that you're saying I have students do group exams before individual exams. It's interesting because the alternative assessment that we did at the AMATYC conference in Nevada was actually one that started as a collaborative activity in class. Um, we called it the Carlos and Anna problem. We couldn't figure out how to do that one here online. But in that one, they start this activity in class, and then the activity gets tweaked. We change the conditions on the activity and we pair them off. And then they go home and they work on that collaboratively together. But that collaboration that they do at home provides the foundation then for something that we can test in class individually. And again, we've been so careful. This is not an easy thing to do anymore these days, but just having them ensuring that they're actually working together and that they're not saying, you take this part, you take this part, you take this part, and you take the other part. So that was a challenge, but I think we came up with some good ideas for that. Um, if anybody wanted to share any alternative assessments that they've tried, or how you might adapt traditional assessments to something more alternative, we can have a short discussion on that.
Is it okay to ask a question by audio?
Yeah, I
I'm
guess so,
not in a
John.
position to use the chat. Sorry about that. But I was wondering, in regards to online, would the functionos, would that be something that you could see happen in a discussion? So someone starts with a first connector and then someone adds onto there and then someone adds onto there?
Yeah, who's speaking? I can't, who is this?
Oh, I'm sorry. My name is Donna.
Hi, Donna. Donna, this Canva, I think that that's very, very possible. And Donna, I just want to let you know, the reason I came up with this idea for this setting was because I told John that we actually, in my geometry class, we created fractals on the Canva whiteboard, and we created the successive iterations of the fractal. The students worked together on the Canva whiteboard to create the successive iterations of the fractals. So I think that if they can do that on the Canva whiteboard, it was very, very successful. I can't imagine why they wouldn't be able to do this, digitally, with function omnos. I mean, Canva has basically what you need, rotating and text, and that's basically it. You just gotta upload your shapes onto there.
So we are mindful of the time.
Oh dear.
Thank you. I mean, we really appreciate everyone's engagement, and just thank you so much for taking the time to join us for this session. We hope that you see some ways to adapt these assessments, or even variations of it in your own practice. And so we do have our contact information here if you want to reach out and bounce off any more ideas. But we're really appreciative of your interaction and just sharing all your thoughts. And thank you so much for letting us be a part of this webinar series. Thank you.
Yeah, please reach out. We'd love to hear from you. Thank you so, so much. And thank you to Kelly for all of her support through this. Thank you.
Thank you both. They were amazing in that entire presentation had to be reworked to be done online. So I'm so very appreciative of them for figuring out how to do all those things. As Donna was asking that question about doing this online, I've tried to do some like debate math things. We're in the passing period, so I'm just gonna filibuster. I'm doing the Bob Capetta vamp if you've ever been to yeah, exactly. So I was gonna say that when I've done that, it can be really hard to have something where they have to pass things off online because they have to be like, the next person needs to be on it and do their part before I can do my part. And it kind of gets frustrating. So having some sort of accountability, if you only at the place one pair, it wouldn't be bad because you just do your pair. If the person hasn't done their job, you're done. But if you're trying to have them build something bigger, I could see that being a struggle of like, but my person hasn't responded yet, so I can't add another functionomino. So like if I were doing it, I would probably just have them add two, put their name on it, write their reasoning, have to use two different reasonings or something, and then let them go away. And then maybe at some point taking a screenshot of it and having them sort of assess someone else's or something, not a screenshot because we're not allowed to do that, but you know what I'm saying? Something with a final product or maybe some debrief. I know my suggestion to Eileen and John was giving them a student like that assessment question, right? Like, because I love the idea of doing this activity, but sometimes students don't see the connection to what they're doing in class and what's going to be on a test. So putting a question on there with, hey, a student made these two links. What do you think their reasoning was? And making them sort of do it again in that setting so they can really see the value. You can all share. I'm sorry. I don't need to vamp that much. This is our time between sessions. Oh, I need to stop the recording.
You do bring up a good point of just thinking